Okay, I'm going to do one last example of the binomial theorem, and this one is going to be not quite as complicated as example 2 that we just did, but a little bit more complicated than the very first one. So the example we're going to do here is x plus 4 to the 4th power. And really, this one wouldn't be terrible to actually multiply out by hand, but it's still not really ideal, mostly because there's a lot of room for error. Since my exponent is 4 here, I need to look at the 4th row of Pascal's triangle, which right here is going to go 1, 4, 6, 4, 1. That tells me my coefficients. Again, it was 1, 4, 6, 4, 1. So when we start to expand, here's my first coefficient. The first part of my binomial goes to whatever our power is. The second part to the 0 power. Next coefficient is 4. Now x is going to lose a power. 4 is going to gain a power. Next coefficient is 6. X loses a power. 4 gains a power. And keep going. My next coefficient is 4. X is going to be to the 1st power now, and 4 is to the 3rd power. And finally, plus 1. X is to the 0 power now, and 4 is to the 4th. Now, don't forget that each time the sum of our powers is going to be whatever power we're expanding to, the 4th power in this case. Add each power together, we get the 4. All right, let's simplify now. 1x to the 4th, 4 to the 0. You don't really need to write 4 to the 0 power, just x to the 4th. 4x cubed, 4 to the 1st. Well, 4 to the 1st power is just 4, times the 4 out here already. 16x cubed. Now I have 4 squared is 16, times 6 is 96, plus 96x squared. Okay, looking at the 4 cubed first. 4 cubed is 64, times our 4, we have 256. X to the 1st power. And then finally, 4 to the 4th power is 256. Okay, this is a nice easy way to expand our polynomials. And again, we could have done to the 4th power by hand, x plus 4 times x plus 4 times x plus 4 times x plus 4, but this takes up a lot less space, a lot less room for error.